check this. I know it's been ages since I did anything with this thing. Well, I need to get this done actually, because yeah, I've just been, it's warm, sunny, it's been warm weather actually. It's been too hot really to do much, because you know it's like when it's hot and sticky. I've also been tired as well, so because of my other problems, so medically I mean, so I've been just taking things easy lately. Now what I've done is the electro-foil, I have wrapped the foil, sorry, I've coated the foil with some Kapton tape on the inside. The reason for that is so that there's less chance of a short circuit between the coils. Now what I've done is broken the lugs off the top of my canopy. I've just broken them off, which I'll stick them back on in a minute, because it holds the wires in place. I had to do that so I could get the foil on there. Now what I'm doing is I'm wrapping the foil around the coil for now. I can add the other foil tubes later on adjacent to this. I decided, because this foil is quite springy actually, it's quite hard to wrap, and because it's so springy, so I've been trying my method of wrapping it around my plastic former to get the shape right. It sort of works, but to be honest with you, this foil, it's so springy. I have to wrap it a lot tighter than that too, because it springs back out slightly. So what I'm doing instead is I'm basically wrapping it around a pen or something, like my knife. It works just probably better actually. Also I'm using my my hook thing. I'm trying to move things out because I have a tendency to knock things over when I'm doing live streams, as you know. So now I lost my hook. My oh, there it is. Not my hook, my pricker thing. Because what I'm doing is I'm using this to curl it, basically, to start with. So if you rub it sideways, you can get to curl a bit. Now it doesn't work so well with this, it's so thin. I tried that and it didn't really work. So yeah, the only way I've figured out to do this really is to wrap it around something quite tight, and obviously I can use something about that narrow gauge or a screwdriver. So let's try the screwdriver method, because this is pretty hard to coil up. So if I just wrap it around my screwdriver like this, seems to work, but it's very springy, so it's difficult. I'll try and do this. The camera's not exactly in the right place, is it? Sorry about that. Right, so if I can get this started, it's getting it started that's the tricky part. Now I could put some tape down here and get it. Yeah, actually that might work. I don't know. Let me just try that first. No, if I do that, I'll never get it off, will I? No, I probably won't get it off easy. So anyway, I'll put the Kapton tape on. Now I'm just going to coil this around the screwdriver to get it round as possible. Actually, I need to move the camera back because I want to be near the edge of the table. You'll see why. It's just easier for me to get my hand over the edge. I can get lower down. And really awkward it's really hard to wrap this tight. The reason I'm trying, oh, I've got a flat spot now, look. You see, this is what happens. I'm trying not to cut myself because this is sharp. So if I get it wrapped. More or less, that'll have to do. Right. So I've got it wrapped around the screwdriver, quite a nice, well, it's not perfectly round, but it won't matter anyway because the coil that we're putting it on isn't perfectly round either, so I just want to get it so it'll spring inwards, you see, so it wants to wrap itself around the coil by itself. You'll see what I mean in a minute. So, right, now it's tightly wrapped. Now I have to unwrap it a bit so I can get it around the coil. So I've done one side of the coil. So, this camera stand is really... I'm up bright and early this morning. It's about 9:15 AM. I actually woke up a lot earlier than that. The reason for doing it early in the morning is because it's before it gets too hot and sticky, because it's been peak summer right now. It's kind of June 22nd, I think. Was it 23rd? I'm not sure actually. Oh, it's the 25th. Saturday. Saturday. Right. So now you can see it's really wants to stay together now. It's really nicely tightly wound, and I've got to unravel it a little bit, which is the awkward bit because I've got to put it around this wire. I'm trying not to disturb the wire as much as possible because I want the coil to, I don't want it all flopping, springing outwards on me, and you know what I mean. So I'm trying, it's not secured anywhere, I haven't put tape around it or anything. So I'm just going to unravel this a bit, like this. And now I need to get it over this coil. It's not easy to do. The good thing I've got Captain tape on that, so I'll just pick this up. Oh, I just remembered. I forgot to trim some off here. Oops. Yeah, the it's a bit wider than. Yeah, I forgot. Damn it! Oh shucks. Well, I've got to. Right. So I need to cut about, because I'm getting ahead of myself, I've got to trim that bit off. Hang on a minute, can I do this in one go? Shit, I've got to unlock, I'm going to ravel it again to do that. Right. It's not critical exactly how much, let me just I just want to get it started about, it's about that. Ooh. Right. I'm saving all the bits to cut off because you never know, they might come in handy. That should be about right. Yeah, it's about right. I'm trying not to damage the wires. Because the foil could cut the enamel off. right up to this edge, right up to here. If I can, it might be stuck down on that plastic a bit. Right. Okay, it's around the coil. Right, so just tuck that around that. I can wrap it, I can pull it tighter. Now I've got to put the pegs back on. You see how it goes on. So now I've got to pull the tension back on the wire. And there's some strands of the wire at the back here that have to go over them pegs. It's a bit awkward to show you this one. Right. We're getting there. It's working, look. Sort of. It's actually a double layered on the outside. I'm not worried about that. I just wanted one layer on the inside, and so I can tape this up and tighten this up on it. Let's get this back. I'm just trying to get the hooks. These little plastic hooks down here, I've got to super glue them back on, because I could use acetone and melt it back on, but I'd have to hold it there for too long. So the super glue is probably the best way to do that. So it's instant. Let's see if I can get my little pointy thing and anybody that says, oh well, why didn't you do this before you actually wrap the coil? Well, that's the problem. Wrapping the coil around here would mean that the foil would be uncoiled and it would be splayed outwards, and then trying to wrap the foil around it later would be even harder. So this is probably the easiest way of doing it, actually. I'm trying not to damage the wires. So it's better to use my fingernail, actually, but obviously this foil is making this coil a bit tighter now. So I'm going to try and loosen it from squeezing it down on the other end. I'm hoping it's not going to short out. Better not. I'll check the DC resistance later on to make sure everything's good. Okay, so seems to be easy. I'll move my little hooks over here. I think I'll use my plastic tool. It's less likely to damage anything. Yeah, that's better. I can push it. That's got that one. Right, if I can super glue that in place. So this hook here has to be super glued on. Back on. I'm just going to put it in position. Get it lined up. And hold it with my finger. So it's not lined up yet. Right. So if I can line it up. Right. So if I get my glue now. Just get this lined up and put a drop of glue on that. I don't know if you can see properly on the camera. I line it up. Don't want to get it on my fingers. Right, hold that still. I think it's stuck. Oh, no it hasn't. I don't think it's sticking. Hang on. Get it. Oh, right, I definitely got it in there now this time. Put it back and hold it. My thumb is getting tired. Ah, it's hurting. I need my pliers. Where's my little pliers? My thumb, I've got a big dent in my thumb now. Uh oh, it moved. Right, I've got it in the right position. Where's the camera flipped upside? No, that's right. I think it's sticking. Let go of it. Looks like it wants pushing down at the front a bit. I've definitely got it lined up. Right, see if I can get the other one on. Actually, it'd be best to give it a minute or two, because to let it harden a bit, because if I put stress, if I get my plastic tool and I start pushing on here, it's going to pull on this one. I don't know, let me just see if it's going to... I think it's stuck. That wire has to be at the back of there. It's definitely stuck on this end. Good. Trying to get this wire. I better just get my meter and check that I haven't done any harm so far. I can't remember the impedance of this. I think it's supposed to be 3 ohms or something. It's been a long time since I measured it. I could go back in my videos and look, but let's just check. I'm not sure what it is. Oh, it's 5.2 ohms. Well, that's good. Yeah, I remember now. 5.2 ohms, yeah, so we haven't got any shorts, that's a good thing. Yeah, so the impedance of this coil is 5.2 ohm. Good thing I measured it, because if I do if I short any windings out, I will know now. Can't seem to get that wire back far enough. It's got to go. See these little, the peg that broke it off, right? I broke the thing off, right? It sticks up a bit, and the wire is not over the other side of the peg. So, and I can't stick this peg on until I get this wire on the other side. And what I'm trying to do at the moment is just bend the wire and push it a bit, because obviously this foil is taking up some room, taking up some slack rather. So I'm squeezing this end to make this end come further up. try using this end. It's a bit bendy though. I could use the hook. Let me try that. I don't want to rip it. Oh, my hook's a bit... Actually, it's got I bent the end of my hook actually, so that should minimise the chance of me ripping anything, because this other hook I've got here, the very tip is bent over backwards. I don't know if you can see that. You can see it's bent. I bent it slightly back, so there's less chance of ripping the enamel off. Good thing. It's probably the only thing I can use really right now. I went over the other side of the plastic thing then, it just clicked under. Good. Squeeze it down. Sorry you can't see it. I've got to, let me try and move the camera a bit. It's awkward. Let's see if we can get you a better view. It's hard enough as it is without trying to film it as well. Now the camera's right in my eye line. I saw something then, I don't know what it was. Was it her hair or something? I hope I haven't snapped the coil. I'll measure it again in a minute. Better not, otherwise I'll be back to square one. I could get my soldering iron and melt that lug down a bit. Let's just double check the impedance to make sure I haven't messed up anything. Oops. I can't see. Flipping heck. We're good still. I haven't knackered anything. As I said, this is a test coil because it's only got one coil on one side, you see, there's not one on the other side. So I'm deliberately doing it on this coil to test before I go any further, because I don't want to do it on all, what was it? I don't want to repeat this task 6 times if it's not going to work on this one. So have I got that far enough down? I could stick my plastic glue on this one I suppose, but I'll squeeze that other end down a bit. Well, I know what I could do. If I put some acetone on here, the opposite end, it will allow the wire to give a bit. Because acetone won't touch polyamide, which is what often what they use to coat the wires. So if I squirt some acetone on this end, because I did put some plastic glue on here, you see, originally. So if I give that a bit of acetone, it will soften anything that's holding it, and it'll give me a little bit more give. And I'll put some on this end as well. So the acetone will just make that hard plastic become slightly soft. Oops, I nearly knocked my camera over. I'm nearly there. I just want to get that wire over the edge. There's a frigging fly buggering me. Ah, something just popped out. I think I've got there now, nearly. I am trying hard not to break anything. Damn fly, go away. You probably can't see it's a midget. I'll get my screwdriver and use a bit of leverage here. Use my pointy pricky thing, and I'd use a bit of leverage. I think that'll work. Now, let me just see if I can get this thing back on here. I'll see if I can super glue it on, if it'll go into place. Not quite. That wire is still in the way. It's my fingernail. I think it's nearly there. Actually, if I bend this up, bend this face towards me up a bit, I should be able to, it should snap under. I'll try. If I don't want to break it, I can mend it if I do. That might give me just what I need. I think it's there. I think that's it. I think I got it. I think it's over the lug edge, over that edge. Now, what I was going to do now is, instead of trying to super glue this one, I super glued the other one. I'm going to use some of my plastic glue to stick this one on, because it's so I use this plastic glue that ABS plastic I melted down with acetone, and it will make a much better bond eventually when it dries. So I'm going to stick some of this glue on here because it's flexible as well, and it'll also hold the windings. So let's just get this. It's not coming out. Oh, there we go. Right, so stick that glue on there like that. and it'll take it'll probably dry in about an hour or two. I don't have to hurry with that, it's not like super glue. And I'll stick that peg back on now, and it should hold it, and as it shrinks it tightens up. Alright, where's my little leg? There's the leg, and we'll stick this on like that. All done. And when that stuff, that ABS melted plastic, when the acetone dries out of it, when it sets really hard, and it will be as good as the original. So there we go, I've done that. So those pegs are back on to hold the wire, and the one that's super glued is that one, so that one's a rigid job, and I could put some extra glue around that later. But now I've got the foil installed, which is the important thing. I know everyone's been waiting for this for how many weeks, I don't know, but because this end's open, I can trim it back if I want, but I was going to leave it for now, because my idea is, as I was explaining in the live stream I did about the 3D model, was I was going to wrap another circle of another tube of foil adjacent to this one next to it, like a figure, so that the two would effectively create a figure of 8 shape, so that the magnetic field would rotate around, and that when the other foil tube adjacent to it was energized, it would create a backspin on the flux lines to create anti-drag on there as well, so that it would overcome that slight discrepancy, that slight error that I get, where there's always a cogging point in the rotor assembly. So even when it gets to the end of the chain and it switches from one, it transitions from one field to another, there's still a sticky point there, and I'm trying to overcome that sticky point by doing that. So I'm going to leave this foil open for now, because I'm going to bend it back out of the way if I want. And we've got a bit of an air gap in there, which is fine. We can see air through there. We can see all the way through to the back there, so I don't mind having an air gap there. That's okay. I don't want it to, you see, if I pushed it too flat and made the coil too tight, it will be less able to pick up flux lines that are coming from the outside here. I want to capture the flux lines from the rotor as it's passing over here to travel around the back of this area. So having it sticking out is good, and it also reduces the cogging effect, which is, this will introduce a small amount of cogging anyway, I think. I'm not talking about the lens drag, I'm talking about the cogging effect, which is a different thing, and that's just basically when you put a piece of steel against a piece of magnet, you always have an attraction, so you'll still get the cogging part of it, which is not to do with the drag when you're inducing equal opposite reaction. It's a different thing. So, you know, people get that confused actually. It's not the same thing. When you energize a piece of copper, it induces a separate field. That field is not the same thing as the static attraction to a piece of iron. That's a constant. That's a constant, whereas the reactance of an electro-energized coil is a variable. So there's a difference, because that's a variation. It varies in its intensity, and it's either repulsing or attracting. It's doing one or the other. It's not doing both. Whereas, yeah, you get the idea anyway. So anyway, I've got my foil on there, so there's no reason why I can't stick this on actually and do a little test tonight. Oh, this is moved. This peg's moved slightly, look, since I stuck it, look. Actually, it's moved slightly, but I'm not worried about that. It's moved out of position slightly, but I can easily move. It doesn't have to be perfectly lined up. I mean, this peg, I can just get my pliers and move it a bit back a bit. I'm not worried about it being slightly out of position. It doesn't really matter. As long as it holds the wires in place, that's all that matters. So that's it for now. So I'm going to let this dry, and later on today, I think my bottle wants to clean. Later on today I'm going to do a test with that coil. Let's just clean this up because it's getting a bit glued up. Where's my acetone? Otherwise my lid will get stuck on if I don't clean it. There's a lot in that bottle still. I haven't used much of it. Actually my lid is feeling a bit tight, so what I'm going to do is I'm going to put some in the cap acetone in here. Clean the cap out because it's a bit sticky. That's better. The threads were getting clogged up. So well, there's nothing to stop me from putting it back on the on there now. Actually, letting it dry in situ, I suppose I can do that. I actually had it on this way around, so I'll stick it back on there. My elastic band might not go on there now. Or maybe it will. Can't see the other end. Where's my torch? back on. Not quite right, hang on. Get it lined up. What's catching? Ah, it was that one. Right. The foil's moving a bit. I'm interested in to see how much more cogging there is. Very little. That's good. So if I take the belt off, this thing keeps dropping. Oh, I've got the torch resting on it, pulling it down. Right. That elastic band wants to be. Oh, I see. I have to put these back on. Pulls that up a bit. Better. So if I bring the camera over here a bit, the wire's a bit short. Let's see. Sorry about this wonky. Yeah, I said I was going to test tonight, but why not? Why not just do one now? I'm just going to turn the power supply on. It's charging up the supercapacitors. Right, so how much of a cogging have we got? Not much. Very little, because there's a tiny bit of cogging there, which is brilliant, because I was hoping, that's why I wanted to use thin foil. If you're using thick iron, you get more. The generator tends to be turn it on, anti-cogging anyway, and it's the way it works. So see if we can see the LEDs. I'll turn the big light out, put the RPM meter on. I want to check current when I put a load over that coil. RPM meter's just off camera actually, let me back it out a bit. I'll turn that big light out. You can see the LEDs down here a bit better now. Oh, it is vibrating a bit, not much. Oh, my belt's coming off, hang on. What have I done? We'll knock this out of alignment. I'll get this belt stay on the right pulley. Why is it not? There we go. Right. So the LEDs, these white LEDs are coming up. So if I get voltage, AC voltage on the I'm going to put the oscilloscope on it because it's the wires that put it down here. Oh, where's the other wire? There we go, that's the other one. It's already up to 1200 RPM already. Right, now the voltage on, oh, it's a lot better actually. The voltage on that one coil is 8 volts peak to peak. Let's have a look at the oscilloscope. If you can see the oscilloscope, I've got the stand on, so hard to move closer. I know what I'll do, hang on. Just take this whole thing off the stand. Oh! Right, so the trace coil that we've just put the 2 volts, right? So put this back on the stand. What I want to do now is see what happens when I put short circuit across that coil. 2.32 volts too well, so I'm just going to put short circuit current across that. So there's my meter. I don't know if you can see that. Maybe not. I think maybe no. I've got it on milliamps. Ooh, 200 milliamp range. Damn it! I need to hook this somewhere. It won't fall. Right? Can you see that? Yeah, I think you can. Right, I'm going to short that coil out with my meter. My back is killing me. Oh. So the wires come down here, right? You can't see, but the wires for that are connected to this coil are terminated at the oscilloscope down here. So let's see what current we get from that coil. It's gone over 200 milliamps. I took it off. It shot over 200 milliamps. It overloaded my meter. Do it again. Oh, I lost it. I can't keep my meter probe on it. The sparks. Look at that. I took it up. It's not dragging it down really fast, is it? I can't seem to keep my meter on it. I really want to test it with an LED, you see, on there, or under the load. I'm just trying to think what I could stick. Oh, I might have a resistor line around somewhere down here. Let's see. Put it through let's put it through a resistor of some sort. Let's see if I've got a 10 ohm resistor or something lying around. Hang on. Or actually a 1 ohm or something like that. That vibration's coming from the foil. It's a right. See what I've got in here. What's this? I can't remember. 1.2k, that's a bit too high. I've got a 1 ohm. I've got a 1 ohm 7 watt. Try that. Right, so we're at 1300 RPM right now. Right, so I'm going to put my clips on here. So I'm going to clip one end to one end that goes to the oscilloscope, which is to that coil. Clip my resistor on the other end. This is 1 ohm load, so right, let's put the other end to the other leg of that coil. Ow! Caught myself. Right, we're at over limit and it's dropping, but it's not dropping too fast. 1300. We're still over limit. We're over 200 million. Oops, I slipped off. Hang on. 1260. Anyway, I don't know how much current that's pushing out, but let me put it on 10 amp range. 10 amp range, and I want this lead in that hole. I'll try that again, see what we're getting. Right, we're getting 280 milliamps, 0.28. That's pretty good. It's at one coil, one little coil. I'm taking it off now. I really want to. You see, that's quite a lot of current, considering that it's slowing down. Yeah, but it's not slowing down all that much. And don't forget, I haven't finished it yet. The canopy, I've still got to wrap some more of these tubes, steel foil tubes, to go adjacent to these tubes to negate that slow down even more. So it's not complete yet. It's not finished by any means yet. But that is very interesting, that we're almost at 200 milliamps at 2.56 volt cyclic, because I'm looking at the oscilloscope and it's actually gone up to 2.56 cyclic RMS right now. That's just that little coil. And I better turn this meter off before I run the battery down. And we'll go a walkabout and I'll show you what the input current is at the moment. So don't forget, this is not finished yet. I've only just put these foils on there. There's lots to do regards to tuning it. I've got to put the other tubes in there next to it, to the figure of 8 method I was telling you about. Right, we're almost at 1400 RPM right now. Oh, what have I done? I've disconnected my LEDs. Ah, that's why it's picked up speed. I must have knocked a wire off there. Right. So, let's go and look at how much input current. Just a minute. Sorry about this, I'm trying to get my... right, input current at the moment is 110 milliamps. 110 milliamps, and we're at it says 9.5 volts there. Right, so the little motor that's driving everything is at 110 milliamps. So that's pretty good. Very little consumption without a load. So yeah, I'm trying to get my phone off this head thingamajig. I've got to put this back on my stand. Right. So that's pretty, I'm quite impressed with that. Oh, I forgot I need to tighten this grub screw. Right, put that back down there. Yeah, so you have to forgive me for being a bit slow lately, because I've just been absolutely worn out. It's hot, it's warm weather as well right now, so I don't seem to get much done. I'm watching X-Files, by the way. I'm just rerunning it. I must have watched it half a dozen times, I don't know. Times I've looked stabilised at 1247, and that's I'm pretty impressed with that oscilloscope reading. Let's just go walk about and have a look. I'm quite impressed with it, to be honest. It's stabilised, it's gone back down again. So because I've got the other coil, the other LEDs are connected now, because I've knocked the wire or something and it's gone off, but yeah. So anyway, I'll say thanks for watching, and as soon as I can I'll get the other foils made up for the entry and exit points of the coil, and I also need to get them, I need to repeat the method really for the other coils, the main coils that are running the LEDs right now. Now, considering at the moment those blue one, the blue trace, is for the LED, right, and it has peak to peak 24.7 volts and a cyclic RMS of 8.16 volts. How much do you think it's going to go up when I put foil? When I put the foil tubes around those coils, just to think. So when I actually do these coils, we're going to have quite an improvement, I think. So anyway, thanks for watching, and we'll see you later.